Okay, here's the narrated answer key for our class problems from today. So for the first problem, what we want to do is for all of these problems, the first step is to identify all the functional groups that have priorities and then determine which functional group has the higher priority or highest priority, and then which ones have the lower priorities, and then put together the list of substituents, alphabetize that list, and then put together the parent name. So that's what we're going to do here. So if I look at this, I have an aldehyde functional group. I have here an alkene, and I have here a ketone. So you have to know your functional groups. The aldehyde has a carbon on one side and a hydrogen on the other of a carbonyl. This ketone has two carbons on either side, which makes the ketone. And so of those three groups, the aldehyde has the highest priority, which means the ketone will have a lower priority. So now let's find the longest continuous carbon chain that contains those functional groups, which we have. Now we have a chloro group here, we have an isopropyl group here, isopropyl group there, a chloro group here, and then what do we do with this ketone group? So we go to our chart, and our chart says that for a ketone functional group, that the ketone functional group, when it is the highest priority, it's an ONE suffix, but when it is not the highest priority, it becomes an OXO group, so an OXO group. So I'm now going to add OXO to the list of substituents. So I clearly have a chloro, an isopropyl, and now an OXO group for the ketone, since it's not the highest priority. Numbering, we number from the end with the aldehyde. That automatically gets carbon 1. I'm going to go across the chain, and so I have a 10 carbon chain. Putting in my numbers for those substituents, we have chloro at 5, isopropyl at 7, and the OXO group of the ketone at carbon 4. And that list is now alphabetized. So now let's start drawing the name out by writing the alphabetized list. 5 chloro, 7 isopropyl, 4 OXO. Okay, so that's our alphabetized list of substituents. Next thing we're going to do is we're going to put together the parent name by using the total number of carbons. So that makes the next part dec. Okay, so we've got a dec. Then is it an alkane, alkene, alkyne? In this case, it's got a double bond in the longest chain, so it's going to be an ene, and whenever I have an ene, I'm always going to have to put the number of the double bond in there. The double bond starts at 2. So we've got a dec, 2 ene. Now we put in the suffix of the highest priority group, which in this case is an aldehyde. Going back to my chart, aldehydes have an AL suffix when they are the highest priority, which it is. And so I do not have to number this 1. I can just say this is 2 desa, or desa, des 2 ene dot al. Sorry, des 2 ene al. Okay, because the aldehyde's automatic, gets to the automatic number 1 position. Now, we didn't do cis or trans yet. If I look at this molecule, there's 2 hydrogens that are trans. So what should become before this is the trans 5 chloro 7 isopropyl 4 oxo dec 2 ena. Okay, so that's the way we're going to put together all these structures. For number 2 here, we've got a cyclohexane ring. What's the highest priority group here, or what functional groups do we have? We have a ketone, we have an alkene. Who has the highest priority? Again, go to my chart. I see that the ketone has a higher priority than the alkene. So that means I'm going to number the ketone first. So this is going to be carbon 1. Now I'm going to number to get the next highest priority group, the lowest number possible, which means I'm going to go 2 and 3, and that's as far as I need to go. All right. So we've got a ketone, we have an alkene in a cyclohexane ring. What substituent do we have? We've got a 3-ethyl group. So this is going to be 3-ethyl. And now I'm going to put together the parent name. So this is this is going to be a cyclohex for the total number of carbons. The cyclo indicating that it's a ring. Is it an alkene, alkane, alkyne? It is an alkene. So that means I need the number and the en to indicate that there's a double bond in the ring. And now we need to look at the ketone. And fortunately, ketones always have an ONE. If they're the highest group in the molecule, which they are. And so in this case, it would be 3-ethyl cyclohex 2-ene, and then the ONE would come in at the end of that. Do I need a 1? No, because the ketone is assumed in a ring to be the number one numbered, or numbering starts at number 1 at the ketone. If you had 2-ene 1-one, it would be okay. Okay, so that's that one. 3-ethyl cyclohex 2-ene one. Okay, let's go to the next problem. Now the next problem has a couple of issues because this has an alkene and an alkyne in it. And so the real issue here is that this doesn't quite follow the chart. So if you remember when we went back and had a discussion and what was in Top Hat, number 1, when you have a double and a triple bond, is named as an ene-ine. That means that when we put this structure together, we're going to have the number before the ene, the number before the ine, as in our parent name, as the suffixes. But the rules that IUPAC came up with said that we first of all need to find the longest continuous carbon chain that contains the double and triple bond. And we're going to number from the end closest to whichever bond is closest to the end. So there's no preference given over triple or double bond, whichever one is closest to the end. However, if it was a tie, the tiebreaker would go to the double bond. So in this case, because the triple bond starts the chain, it's going to be 1, 2, 3, 4, 5, and 6. There is an ethyl substituent at 3, so this is going to be a 3-ethyl. All right, now I'm going to put together the parent name, realizing that this is an ene-ine. And so in this case, total number of carbons is hex. The double bond is at carbon 4, so this is a hex 4-ene. The triple bond is at carbon 1-ine, so hex 4-ene 1-ine. And looking back at this double bond, there are 2 hydrogens, and so we can name this would be cis 3-ethyl 4-hex, cis 3-ethyl hex 4-ene 1-ine. So again, we have to remember that there's some anomalies in the naming of eins, and that being the numbering from the end closest to the first group, regardless of whether it's a triple or a double bond. Okay. All right, next molecule. Looking at functional groups, I again have a ketone, and I have an alcohol. And so now I have to look at my chart to see which one of those two has the highest priority. I look at my chart, I see that ketone is right above alcohol, so ketone wins the priority. So that means it's automatically going to be carbon 1. Now I'm going to number clockwise to give the OH carbon 2, because it's the next highest priority, down to 4. Okay, now looking at the substituents, carbon 4 is a sec-butyl group because it has 4 total carbons here. It's got 4 total carbons, and the attachment point here, just looking at this group, that carbon is that carbon is secondary. So that's where the secondary butyl group comes from. Now, the alcohol is not the highest priority, so what is its name when it is a substituent? We go to the chart, and when it is the highest priority, it's OL. When it is not, it is a hydroxyl group here. So hydroxyl means that's what we're going to name it. So we're going to come back here and say this is a 2-hydroxyl. Well, let me make sure. I think it's hydroxy. It's hydroxy. So we got a 2-hydroxy group and a 4-sec-butyl group. In terms of alphabetization, butyl wins because it's sec, it's hyphenated, and then 2H. So let's set up our list of substituents. We've got a 4-sec-butyl, 2-hydroxy, and now the parent name, this is a cyclohex. Alkene, alkane, alkyne. There's no double bonds in the ring, triple bonds in the ring, so this is a cyclohexane. And now the suffix of the highest priority group is ketone, so that is ONE. So this is 4-sec-butyl, 2-hydroxy, cyclohexano. Okay, so that's the name of that molecule. Okay, another ring, and in this case, we're going to look at the 2 functional groups that are present. We have an aldehyde, and we have an alkene. Which one of those has the highest priority on the chart? The aldehyde beats the alkene. Now, in this case, though, the aldehyde is not attached to a chain. So in this chart and in the revised chart that I have, the brackets indicate an acyclic, but the no brackets indicate what you call it when it's a ring. So coming up to the aldehyde, CHO, where it's attached to a ring, which is no brackets, that is called a carbaldehyde. So when I look at this molecule, this is going to be, the suffix name is going to be carbaldehyde. So that's actually going to be the last part of the name. Numbering occurs at the carbaldehyde. Now I'm going to go clockwise to give the double bond the next highest priority group, the lowest number. So I'm going to go around the ring like that. What would happen? Well, first of all, I number clockwise or counterclockwise, so I give the next highest substituent the next highest substituent the lowest number. If there was a tie, we would go to, for instance, alphabetization. All right, so what do I have in terms of my substituent? I have uno substituent, which is 5-bromo. This carbaldehyde is going to be part of the parent name since it's the highest, because it's the highest priority functional group. So my one substituent is a 5-bromo. This is a cyclopent, 5-membered ring, alkane, alkene, alkyne. There's a double bond in the ring at position 2, so it's a 2-ene. And then finally, it's a 2-ene carbaldehyde. So this is 5-bromo cyclopent 2-ene carbaldehyde. For rings less than 7 or 8 carbons, all the double bonds will always be defined as being, quite honestly, cis within the ring system. So we don't have to worry about identifying double bonds as cis or trans when we have molecules within when we have double bonds within rings. Okay, next one. Longest continuous carbon chain with the triple bond. There's only one functional group in here as a triple bond, so it looks to me like this is the longest continuous carbon chain of 1, 2, 3, 4, 5, 6, 7. If I went the other way, 1, 2, 3, 4, 5, 6. So that's the longest continuous carbon chain. I am going to number that from the, oh, you know what I forgot? I forgot the double bond here. Or did I? Hold on, no double bond there. No double bond. So this is the longest continuous carbon chain. Okay, and so that is we're going to number from the end closest to the triple bond, which in this case is going to have to go 1, 2, 3, 4, 5, 6, and 7. All right, so we've got a 7-carbon chain. We have one substituent at carbon 4. This substituent is an isopropyl group. So we have a 4-isopropyl. And now we have a 7-carbon chain. So now we're ready for parent name. The parent name is going to be Hept. This is an alkyne only. So this is going to be a Hept 2-ine. So this is 4-isopropyl Hept 2-ine would be the name of this, would be the name of that molecule. Next molecule is an ester. So the first thing we do when we name esters is that we determine the alkyl group that is attached to the oxygen attached to the carbon-oxygen double bond. So this is going to be named, that alkyl group's name is going to come first. In this case, this is what kind of functional group? Tertiary pentyl. So this is a tertiary pentyl. How do I know that? Because number one, I've learned or memorized my list of alkyl groups. But if you're stuck, 1, 2, 3, 4, 5 carbons makes it pentyl. Is it a straight chain? No. Does it have an iso group? No. Iso groups being CH3, CH, CH3. So now we look at the attachment point here. What kind of attachment point is that? That has 1, 2, 3 other carbons attached to it. That makes it tertiary. So we've got a tertiary pentyl group. Now I'm going to use this as my parent chain. And if I look at my chart says for esters up here that these are named as alkyl OATs. So alkyl, then the parent name with the suffix of OATE. All right, so now I'm going to look at my chart here. I'm going to go 1. I have to start numbering at the carbonyl attached to the oxygen of the ester. So 1, 2, 3, 4, and 5. what functional group do I see here? Well, actually, I probably should have started with this and said, well, I have a ketone and I have an ester, but because the ester comes at the end of the chain on the chart, the ester is above the ketone. So we have a ketone. Now remember, we have a ketone that is not the highest group, and so therefore, if we look at the chart, when a ketone is not the highest priority group, it becomes an oxo group. And so we have here a 3-oxo substituent. We also over here have a 4-methyl substituent. So we have a 4-methyl, 3-oxo, and then we have our 5-carbon chain. So let's put together our alphabetized list of substituents. So we start the name with terpentol. Next would come 4-methyl. And just a tiny thing, notice that there's just a space between the terpentol and the 4. There's no hyphen. That indicates that this is the group that's attached to this oxygen. So we've got a 4-methyl, 3-oxo, because M comes before O. Now we're going to put together the parent name. So we've got a 5-carbon chain, which means we have a pent. Alkane, alkene, alkyne. It's an alkane, so this is a pentan. And then the final suffix for an ester is OATE. So this is a terpentol, 4-methyl, 3-oxo pentanoate would be the IUPAC name of that molecule. All right, the next molecule is kind of one I decided to go back to the beginning when we first started to learn cyclohexane rings. There are no functional groups in this molecule that have any kind of priority. So when that happens, we have to number the cyclohexane to give us the lowest total sum of substituent numbers. And so in this case, I have to number either 1, 2, 3, 4, or inside here 1, 2, 3, 4, because that's the lowest sum of substituent numbers I can get of 1 plus 2 plus 3 plus 4, which is 10. So I have to start at the ethyl group or I have to start at the methyl group. To tie break this, which is alphabetized first, methyl or ethyl, and ethyl wins. So ethyl would be where I'm going to start numbering, and then I'm going to go clockwise down to the methyl. So I'm going to go ahead and erase those numbers. Okay. If there was a tie here between like 2 methyls or 2 ethyls, then we would go bromo versus terpbutyl. But there's not. We have to number at the end. We have to number with the group that's highest alphabetization. So we do have a bromo. And what do we have here? We've got a 1, 2, 3, 4 carbons with a tertiary attachment point. So this is a tertiary butyl group. Okay, so now I'm just going to put together my alphabetized list. So it appears as though we have a 2 bromo first, then we have a 3 tertiary butyl group, then we have a 1 ethyl group, and then finally we have a 4 methyl group. So 2 bromo, 3 terpbutyl, 1 ethyl, 4 methyl. Again, for the terpbutyl, because it's hyphenated, we alphabetize on B. Okay, that's my alphabetized list. What's the parent name? This is a cyclohex. Alkene, alkyne, alkane. cyclohexane. Okay? So when there's no high priority functional groups in the cyclohexane ring, we just go back to finding the numbering scheme that has the lowest possible sum. Now, I have two other problems here that I whipped up. So what you can do is, if you want additional practice, you can go ahead and take a look at these. You can go ahead and take a look at these and try and name them, stop the video, and then you can go back and see whether you were right or not. Okay, so I'm going to start with the first one here, this ester. Right, because this is an ester, I'm going to name the alkyl group attached to the oxygen, and so that's going to be a cyclopentyl group. So cyclopentyl what? Well, if I look here at the rest of the molecule, I have obviously an ester, I have an alkene, and I have a ketone. Which of those is the highest priority? The ester, followed by the ketone, followed by the alkene. So the ketone now, is just another substituent, and so we'd have to look at our chart and say, okay, what is a ketone? When it's not the highest priority group, it is an oxo group. So therefore, this ketone is going to be common oxo group, and I'm going to throw it in the alphabetized list of substituents, and it's going to go there in that list. Okay, I'm going to get rid of this box, because now what I'm going to do is circle the longest continuous carbon chain that contains the carbonyl of the ester and the double bond and the ketone carbon. So what do I have here? I have a methyl group here. Got a methyl group here. And then the oxo group is going to be the other substituent. And what did I forget? I forgot the chloro. So I've got a chloro, oxo, and methyl. So now we're going to number from the ester carbonyl, because that has the highest priority. I'm going to go 1, 2, 3, 4, 5, 6, 7, and 8. So let's put together our alphabetized list. It seems like, well, let's put it up here. Cyclopentyl, 4 chloro, 7 methyl, 6 oxo, and so there's my cyclopentyl, because it's the group attached to the oxygen of the ester, and then 4 chloro, 7 methyl, 6 oxo is my list of substituents, alphabetized. So now we have an oct, alkane, alkene, alkyne. It's an alkene, so oct 3-ene. What's the final, the highest priority functional group substituent name or suffix name? OATE, because it's an ester. So this would be a cyclopentyl 4 chloro, 7 methyl, 6 oxo, oct 3-ene, O8. Okay. The last one. Cyclohexane ring with a double bond. So an alkene, an alcohol, and a carboxylic acid. Alright, which one of those has the highest priority as far as the functional groups go? It's going to be at the top of the list, the carboxylic acid. Now, because this carboxylic acid is attached to a ring, I'm going to use the carbon without the brackets, and so this is going to be a carboxylic acid. And notice, I don't think this is a typo. There's a Y, or there's an I there instead of a Y. But that is going to be the name, is carboxylic acid with an I. If you put a Y in it, it's okay. So that's going to be our last name of the suffix. The alcohol functional group becomes a hydroxy group when it's not the highest priority, so this is going to be a hydroxy group, and the alkene, of course, is going to be an ENE when we take care of that name. All right, so now let's put together our list of substituents. Remember that the carboxylic acid is the parent, is the highest priority functional group, so it's going to be the end of the name. It is not a substituent. But if I'm going to number, I need to number starting at the carboxylic acid since it has the highest priority. Now I've set up this molecule so that if we go 2 and 3 we get to a double bond, or if we go 2 and 3 we get to the alcohol. So now I'm going to go in the direction to give the higher priority group between alkene and alcohol the lowest number. If I forget, I go back to my chart, which says alcohol outranks alkene. So the alcohol outweighing the alkene means I'm going to go 1, 2, 3, 4, 5, and 6. Okay, so I've got in terms of, I only have one substituent here. That's the OH group. So I've got a 3-hydroxy. Now, 3-hydroxy what? 3-hydroxy, I didn't need that. 3-hydroxy cyclohex. It's almost getting tiring. Alkene, alkane, alkyne. What do I have? I have an alkene, so I got to put the number in. In this case, that number, the double bond starts at 4. So a cyclohex 4-ene. And now the carboxylic acid is the suffix for the final. So carboxylic acid. So we've got a 3-hydroxy cyclohex 4-ene carboxylic acid. Okay. So I think I've gone through all of the possible sort of combinations of different ways to look at this, with some groups being high priority, some groups being lower priority functional groups. So if you have any questions on this, post them on Piazza or email me. But hopefully after you go through these, you have a much greater understanding of naming.